Hello everyone, in this video we'll be solving a hard problem number 4, median of two sorted arrays. The problem statement is we are given two sorted arrays nums1 and nums2 of size m and n respectively. We need to return the median of the two sorted arrays. As a follow-up, the solution's time complexity should be O of log of m plus n. In example number 1, nums1 contains 1 and 3 and nums2 has 2 in it. If we combine the array together, it will have 1, 2 and 3. As median is the centermost element in an array, the output should be 2. In cases when there are an even number of elements in an array, the median is the average of the two numbers at the center. If we try to solve this problem without considering the time complexity requirement, it is a very easy problem to solve. All we need to do is, using two pointers, run and iterate through both of the arrays simultaneously and build a combined array. And after the combined array is created, based on the length of the combined array, we can calculate the median, either take the centermost element or calculate the average of the two elements in the center. But with this solution, our time complexity will be O of m plus n, as we are running the iteration on both nums1 and nums2 to build the combined array. And the space complexity is also going to be same, as we are creating a combined array of all of the elements in nums1 and nums2. Now let's discuss a different approach where we can cater to the time complexity requirement. Whenever I see a time complexity of log n, the first thought that comes to my mind is to use binary search algorithm. But it's not very evident how we can use binary search algorithm to this kind of a problem. Before we talk about that, let's discuss few of the basics which we can use to solve this problem and how binary search will be useful. Between the two arrays, we have a total of 11 numbers and the midpoint is going to be 5 if we do a round down. Based on that midpoint, the median of the two arrays should be 3, as it is the centermost element in the combined array and it has 5 elements on the left and 5 elements on its right. Now we need to determine how many elements on the left hand side of the median should be coming from n1 and n2. As we know the length of the combined array, we know how many elements should be there on the left hand side of the midpoint. So let's start with an assumption that we need half of the elements in the smaller array between n1 and n2, which will come in on the left hand side of the combined array. Because n2 is smaller, we'll use that to apply binary search algorithm. So we'll use two pointers, left and right, left pointing at the first element, that is index 0, and the right will be pointing at the last element, that is index 3. Using left and right pointer, we can calculate the midpoint in n2, which will be pointing at number 2. We continue with the assumption that the first half of n2 will be there in the left hand side of the combined array. So we have identified 2 elements out of the 5 elements that we need on the left hand side. So based on those two numbers, we can easily figure out how many numbers we need from n1 to be placed in the combined array. That is 5 minus 2, so we need 3 numbers from n1. And as the array is already sorted, we'll be taking the first 3 numbers from n1. So we'll draw a partition between 3 and 4. Now that we have 5 numbers on the left hand side, we now have to calculate the median. Because there are odd numbers between the two arrays, we don't need to calculate the average of two numbers like we did for even numbers. If you look at the combined array, after we have the first 5 numbers identified, the next number is the median, because after that we have 5 another numbers on the right hand side. Similarly, now that we have 5 numbers between n1 and n2, the median should be the number right after the partition that we drew in n1 and n2. We can't say for sure if it will be in n1 and n2 unless we compare the next value. So the median will be calculated by applying the math.min operation on the next element after the partition, which is 4 and 3. So between those two numbers, 3 is smaller, so that will be our median. This is only possible if we have a total of odd elements between the two arrays. If we have an even number, we need to calculate the average. So that is a different approach which we'll be discussing next. We have so far covered a very happy and basic case where we did not have to play around with the left and the right pointer using binary search algorithm. In the next example, we'll try to cover that and also try to solve a case where there are a total of even numbers between the two arrays. Let's work with this example where the total number of elements are 12 and the middle is going to be 6. The median of this combined array is the average of 4 and 5, which is 4.5. Similar to the previous approach, we'll use binary search algorithm to solve this problem. We'll apply it on the smaller array, which is n2. Starting with the left pointer pointing at index 0 and the right pointer pointing at index 3, the midpoint is going to be index 1, which is number 2. So we'll draw a partition right between 2 and 3. So we have so far 2 elements on the left hand side. As the middle is 6 and we already have 2, we need 4 elements from n1. So we'll draw a partition right between the two 5s. Now before moving any forward, we need to first verify that the elements that we have on the left hand side are all valid. That is, we need to make sure that the values on the left hand side are smaller than the values on the right hand side. So if you look at the last value in n1, which is 5, it is greater than the next element on n2 after the LHS. So this makes it invalid. We cannot have 5 on the left hand side and 3 on the right hand side. The array is no longer sorted. So we need to fix that. The formula that we are using here is the max of LHS should always be less than or equal to min of RHS. This applies to both the arrays. The max of LHS on N1 should be less than or equal to the min of RHS on N2 and vice versa. We don't need to compare within the same array because the array is sorted. So the 5 in this case is always going to be less than or equal to the next element in N1. So we need to limit this comparison to the other array. Now that we know that the condition is not suffice, we need to update our pointer. So the left pointer should be changed to midpoint plus 1. This change will also help us define or take more elements into RHS from N2 than we were taking before. Now with left pointer pointing at 2 and right pointer pointing at 3, the midpoint is going to be 3, which means we'll be taking 3 elements from N2 and the remaining 3 will be coming from N1. With this change, the partition will now be between 5 and 5 at index 2 and index 3. Now we'll repeat the same check to look at the max of LHS and compare it with the min of RHS. Is the condition sufficed? The min of RHS is 4 and the max of LHS is 5. As the condition is not sufficed, we'll repeat the same cycle of updating the left pointer. So the new value will be left pointer is equals to mid plus 1, which is equals to the right pointer. So both left and right pointer are pointing at the same value. The midpoint is also going to be the same. This means that out of the 6 values that we need on the left hand side, we are getting 4 values from N2. So we only need 2 values from N1. So we'll move the partition again towards the left hand side. Now it's between 4 and 5. Repeating the same check again. So max of LHS is 4 this time and the min of RHS is 5. So the LHS is coming from N2 and RHS is coming from N1. And because the condition is sufficed, we can calculate the median. Because we have a total of even numbers between the two arrays, we need to calculate the average of the centermost numbers. And to get those two numbers, we'll use this formula, which is max of LHS between N1 and N2 plus min of RHS between N1 and N2 divided by 2. The max of LHS is between 4 from N1 and 4 from N2 that's based on the partition that we have drawn. Between these two numbers, the max is 4. And for RHS, as there is no RHS on N2, the value will be between 5 and infinite. So 5 is the minimum. So on the right hand side, we'll get 5. So the average is between 4 and 5, giving us the total 4.5. I hope you were able to understand how we are using binary search algorithm to solve this problem. Because the numbers in N1 in this example were greater than the numbers in N2, we were updating the left pointer. But if it was not the case, then we would have updated the right pointer to shift towards the left to accordingly get the right numbers on the left hand side. This approach is only possible because the input arrays were sorted. If it wasn't, then the first option that we discussed would have been a more suitable choice. There are a couple of edge cases that we haven't discussed. For example, What if all of the elements that we need on the left hand side are only in one of the two arrays? For example, it's only in n1 or n2. In those cases, we need to make sure that we are updating the partition accordingly. And when calculating the math.min or math.max between the two numbers, use infinity or positive or negative when there are no numbers available in the other array. With this solution, our time complexity is O of log of min m comma n. The log is because we are using the binary search algorithm, and min of m comma n is because we are running the binary search algorithm only on the array which is of smaller size. And the space complexity is O of 1, that is constant space, as we are not creating any collection to store the combined array. We are only using couple of pointers to determine the range of the partition. Let me show you how we can implement this using C#. Here's my C# solution. As we want to run the binary search on the smaller array, I'm checking the length of the array, and if nums1 is greater than nums2, then I'm calling the same method again, reversing the parameter sequence. It is to make sure that the first element that is being passed always is smaller than the second one. After that, I'm initializing a couple of variables to determine the length of each of the array and the left and the right pointer, or low or high. After that, I'm starting a while loop until low is less than or equal to the high value. This is part of the binary search algorithm. Inside the while loop, I'm first calculating the midpoint or the partition x based on the low and high and dividing it by 2. This will help us determine how many elements we can take from the smaller array into LHS. After that, I'm calculating the partition that we can place on the bigger array, that is nums2. Next section is to cover few of the edge cases where we need to take all of the elements on the left hand side from either nums array 1 or nums array 2. So we are comparing the value of the partition against the int.min or int.max value to make sure that we get the correct combination. In the next line, we are validating if all of the elements that we have selected on the left hand side are valid. That is, the values are minimum and none of the values that are there on the right side of the partition are less than the current value on the left hand side. These checks are done cross array, that is, the max of left of nums1 is compared against the min right of the second array, that is nums2, and vice versa. If the conditions are satisfied, it means that we have placed the partition at the right spots so that we have valid elements on the left hand side. So we can then start calculating the median by determining if the total number of elements across the arrays are even or odd. If it is even, then we do math.max of the left hand side elements and math.min on the right hand side elements. And when we have the two values, we just calculate its average. And if the total number of elements across the two arrays are odd, we just need to calculate the math.max on the elements on the left hand side of the partition. If the if condition is not suffice, it means we need to adjust the left and the right pointer. So we are changing the values accordingly. To avoid compile time errors, we are throwing an exception at the end. This case will only happen if the while condition is not suffice and there was no output that was returned. And it will only happen if the input arrays are not sorted. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 63% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.